Right now, somewhere in the Milky Way, a star is dying, and when it does, it will rip a hole in the very fabric of space and time. Welcome to the Cosmos in 5. Today, we are diving into the most terrifying and fascinating objects in the entire cosmos, the black hole. So, what exactly is a black hole? Imagine you are holding a bowling ball. Now place it on a stretched rubber sheet. It sinks in, right? It creates a depression, a curve in the fabric. Everything nearby starts rolling toward it. Now imagine an object so incredibly massive that it doesn't just create a dip, it punches a hole straight through. That's essentially what a black hole does to space-time. A black hole forms when a massive star, usually at least 20 times the mass of our Sun, reaches the end of its life. For millions or billions of years, a star burns through its nuclear fuel, converting hydrogen into helium, helium into carbon, and so on. This nuclear fusion creates outward pressure that fights against gravity. But the moment the fuel runs out, the gravity wins, catastrophically. The star's core collapses inward in a fraction of a second, then explodes in a supernova, one of the most violent events in the universe. What remains at the center is so dense, so impossibly compressed, that not even light can escape its gravitational pull, and that point of no return is what we call a black hole. The math behind the madness. The defining feature of a black hole is its escape velocity. Escape velocity is the speed you would need to reach to break free from an object's gravity. Earth's escape velocity is about 11 kilometers per second. The Sun's is about 620 kilometers per second. A black hole's escape velocity exceeds the speed of light, 300,000 kilometers per second. Since nothing in the universe can travel faster than light, nothing gets out, ever. Scientists classify black holes into three main types. Stellar black holes form from collapsed stars and can be a few to tens of times the mass of our Sun. Supermassive black holes are the monster lurking at the center of most galaxies, including our own Milky Way. Ours is called Sagittarius A star, and it contains the mass of 4 million suns. Then there are intermediate black holes, which are still being studied and sit between those two in size. Can we actually see them? Since light can't escape, you might think black holes are invisible, and technically you would be right. But in 2019, the Event Horizon Telescope captured the very first image of a black hole's shadow. The supermassive black hole at the center of galaxy M87, some 55 million light years away. It looked like a glowing orange ring of fire around pure darkness. It was a photograph that took humanity's entire scientific history to achieve. And here is what makes black holes even wilder. Time itself slows down near them. If you were to hover just outside the black hole, time would pass so slowly for you that someone watching from a safe distance would see you almost frozen. Einstein predicted this more than a century ago, and we have confirmed it. Black holes don't just destroy matter, they warp reality itself. Why does this matter? Black holes are not just cosmic curiosities. They play a critical role in how galaxies form and evolve. The supermassive black hole at the center of a galaxy influences how stars are born and how matter is distributed across billions of light years. In a very real sense, they are the architects of the universe. So here is something to think about as we close. If a black hole's gravity is so overwhelming that even light cannot escape, then how did scientists ever figure out they exist in the first place? Drop your theory in the comments, and I will see you in the next episode.